Let's see if we can solve this quadratic equation by factoring. We have 6x squared plus 9x minus 15 equals 0. One thing I like right off the bat is the fact that this is set equal to 0, which is a necessity if you want to solve by factoring. Now, one thing kind of worries me though. We have a 6x squared plus 9x minus 15. That would be really difficult to factor by trial and error, because you've got a whole lot of different factorizations of 6x squared and you have a few of 15, and so it's just a lot of options to look through. But remember, whenever you want to factor, there's one thing you should always do before you do anything else, and that's look for any common factors. So we're going to look at the 6x squared, the 9x, and the minus 15, and see if there's anything common in all of those terms that we can factor out before we do anything else. Now, they do not all have an x. The 15 doesn't have an x. So let's just look at the coefficients. A 6, a 9, and a 15. What's the GCF, a greatest common factor, of 6 and 9 and 15? It would be 3. So they all have a factor of 3 in common. So let's factor a 3 out, and let's see what's remaining. We'd have a 2x squared, we'd have a plus 3x, and we'd have a minus 5. And look how much smaller that is. That's a whole lot fewer options than we had previously before we factored out the 3. Now we just have to factor this quadratic here only, and then we'll be able to see what our answer is. Now, I don't really care how you factor this quadratic. You can do trial and error, you can factor by grouping, you can do whatever you want. This one is small enough. I think I'm just going to do this one with trial and error. So a leading 2x squared, there's really only one way to get 2x squared. If you FOIL two binomials, the only way to get 2x squared would be 2x times x. And so I know those are going to be my leading terms. And then the ending term is negative 5. And the only thing that multiplies to 5 is a 1 and a 5. So it'll either be a 1 and a 5 or a 5 and a 1, possibly with different signs. But we need the signs to be right so that we get a positive 3x for our middle term here. So let's try plugging in a 5 and a 1. I think if I put a 1 and a 5, that wouldn't work, because you get 2x squared, then you get 10x for the outer and x for the inner. That can't add to 3x. So let me switch the 5 and the 1. About a 5 and a 1. So now if we FOILed, we get 2x squared. We'd get a 2x and a 5x. That could give us 3x if the signs were right. We would need a positive 5x and a minus 2x to give us 3x. Now, that's not saying that that's the correct answer, because we still have to make sure the sign works all the way through for all the terms like they're supposed to. 5 times negative 1 would actually give us negative 5 as well. So it looks like we're good to go. Let's FOIL it one more time just to make sure. 2x times x is 2x squared. 2x times negative 1 is minus 2x. 5 times x is plus 5x, which adds to 3x. And 5 times negative 1 is negative 5. So we did it correctly. We factored the quadratic correctly. And so now we have this product equal to 0. Now, most students understand very well what happens or what to do next with these two guys. We're going to set each of these guys individually equal to 0. We'd have 2x plus 5 equals 0, and we have x minus 1 equal to 0, and those are going to lead us to our solutions. But some students get kind of confused with this 3 out front. What is that, another solution? Is 3 a solution? Do we set that equal to 0? Like, what does that mean exactly? Well, let's back up. What does it mean to be a solution of any equation, not just quadratic, but any equation for that matter? It's a value for x that would make the equation be true. That's what we're looking for here. But this first factor here of 3, it doesn't even have an x. So to say it another way, there's no x you could choose that will make 3 be 0. And so since this is never going to be 0, it'll never give us a solution. There are no solutions yielded from this factorization of 3. You could say it this way. You could say, since this is a non-zero term, you could divide the left side and the right side by 3, and it would just disappear, because 0 divided by 3 is, if you divided this side by 3, you'd still get 0. And so this 3 is not affecting any of your solutions. It's not giving you any extra solutions. It's not giving you any less solutions. So it's not yielding any of our answers. So we're just going to focus on the factors that have an x to tell us where our answers are. So here we go. We have 2x plus 5 equals 0. This means 2x would equal negative 5 if we subtracted 5 to the right. And so x would be negative 5 over 2. So there's one solution. So we're finding our answers finally. Here's one solution to the quadratic equation. And x equals 1 would be another of our solutions when you add 1 to the right hand side to solve for x in the second equation. So negative 5 halves and x equals 1 would both be the two solutions to this quadratic equation.